Okay, so a very poorly interpreted train situation. We're just going to talk about this part, don't care about the rest.
It arises from two other constants. He also assumed the laws of physics are the...
Oh, that's the best explanation ever. It's constant because it comes from constants, obviously.
For everyone, regardless if moving or at rest. Now think about it. If two people turn on the flashlight, but one person is
Okay.
standing still while the other person is on a moving train, wouldn't the person standing still see the other person's light as going faster than the speed of light? The reality is no.
How fast is this train going? A lot of these is like, I don't know, is that train going at relativistic speeds?
Be the same as their own flashlight. That's impossible, except if time passes slower for that person from the perspective of this person.
Okay, so that was an ignorant statement made by an ignorant person. And regarded by another person who's not thinking about it correctly. The way it really works out is the only thing that affects light's speed is electromagnetism. Maybe gravity. And of course, the goddamn atmosphere. So if you have an example of light going through water versus through air versus through glass versus through your mom's face, it's not going to go through your mom's face. Not a lot of it. You gotta get through like the skin and everything. It tends to not go all the way through, unless you got like nothing in there. And it goes right through your ears. That's not what I'm talking about here though. The thing about this experiment is it's forgetting that the only thing that's going to affect light is electromagnetism. Okay? So, if you have nothing but air in the space manner, no matter where you're in the train or on the ground. You know why? It has an independent jetpack that doesn't give a damn about you and your travel speed. Literally doesn't matter if you're going at Mach speed or, as he said...
In other words, if the speed of light is constant, time must be relative. Also...
Unfortunately, no, it is not. So, the weird thing about this whole concept is that it leads to the idea of time being able to warp and for some reason work differently than it normally would if you're in a train or if you're on the ground. This is not why trains are late. The thing about it is, and I said this in my statement, it's really interesting, the idea of relativity versus the idea of equivalence principle, where all things are happening equally. Relativity says things are sort of different depending on where you happen to be relative to your local position. It can be totally different if you're somewhere else. That's nonsense. It doesn't happen that way. By the same logic,
gravity is not actually a force, sorry Newton, but rather a consequence of masses bending space-time.
That also doesn't happen. Mass doesn't bend space-time. It's a nice way of analogizing how mass seems to have an effect on matter, and you can represent it as such, but just the same, you could say the same thing about magnetism as bending the area around everything else. But we know full well, and we would never believe anyone who says that, yet we believe this. You're kidding me, right? No. In other words, you need to have a proper understanding of the actual effects of local area stuff in order to know what is actually inflicting its effect from the Earth to the Moon, from the Moon and Earth to the Sun, And Jupiter, which by the way has an effect that's interesting, makes it so that literally because of Jupiter's mass and the sun's mass, they're pulling on each other so that we're not orbiting the sun, we're orbiting, or they specifically are orbiting, maybe all of us, I don't know, are orbiting an area that is slightly away from where the sun is. So this whole idea of the local area space-time curvature has nothing to do. It's a completely separate effect to the effect of what makes, like, the thing that causes the local area gravity, which is strong, is different than the stuff that causes the orbits. Yeah. Because that massive effect is really good and works well nearby, but when you get further away, how do you really explain the relationship between the star and the local planets? There's nothing connecting them, according to this diagram. That's because you don't have the correct diagram, calibration, or whatever else. You're just not simulating the effects whatsoever. Huh. How could they have two separate effects? You gotta wonder. It's like, okay, well, just expand the circles that are surrounding the planets and stars, and then you have all the overlaps, and then you can solve the free body problem. I mean, technically, you can visualize it like that, but it's not the fact that space-time is curving. It's that there's an attractive force, similar to magnetism. In fact, hypermagnetism is probably the real thing that's happening. You're literally being pulled towards the star, but flinging past it so much because of the star's momentum moving forward. Your momentum moving towards it is going to be offshoot all the time, unless the star starts, like, not moving much. If you stop the star from moving and everything else were to also slow down, and you expect it to have an orbit like that, it won't. You're all going to get pulled into the star.
For purposes, though, gravity is a force. But I guess if you're looking for some extreme scenarios involving satellites or black holes that require some relativistic corrections, then
I need you to stop what you're doing.
I will not. Shut up.
that requires some relativistic corrections, then sure.
Thought the universe is a mesh of space and time, and anything
It's not.
with mass bends this fabric. Also, all
It doesn't.
objects move freely on a straight line when moving through space. Gravitation is simply the result of objects following these bent lines which appear straight.
No. If you have something moving fast and it goes near an electromagnet, right? How do you think CERN works? It works by exerting a certain amount of force, which is very, like, a lot of pinprick just stuff all pulling in one direction so that it goes only specifically in the curve around the LHC or whatever, Large Hadron Collider. Those magnetic forces are what make it so that it can change direction. Think about the Earth as a gigantic magnet with certain amounts of like it's not the problem is, how do you, when relating to just magnetism, refer to everything, like, because if you think of magnetism, that makes different predictions versus classical or basic electromagnets and stuff like that. Really? Because relative to actual magnets, the Earth's ability to pull something from far away, or Jupiter's ability to pull something from far away, is insane. And if you really were to do all the sensors and everything, you'd be able to know that there is some kind of pull-push there. So if that's not what they observed, then it must be something else. What is it exactly? That's a good question. But still, it's not just this Benny of space-time nonsense.
To them. If you have a hard time understanding this, you can imagine two people on Earth walking in parallel straight lines. Now imagine one standing on the east coast and one on the west coast of the US.
Yeah, this is the problem
If
because
they both walk north, eventually
what you're talking about is, oh yeah, you're going to have everything seem like relative to the surface of the planet, which is actually the top of the bowl, okay, and the outside space is the flat part of the bowl. Yeah, no, it's not how, that's not the reason for it to physically do that. No.
will meet at the North Pole. Because of the curvature of the Earth, they ended up at the same point even though they both walked straight relative.
So what's happening really in outer space? There's nothing but outer space. But then when you really think about it, if there is some kind of eddy current of stuff that is flowing into the planet as stuff of lower mass or heavy enough, any heavy enough mass, being close enough to the planet is just going to flow in. You gotta wonder what is dragging it inward. So obviously, if you go fast enough, tangential to the circumference of the Earth, if you start going so fast, you'll just fling off. Whoop.
Themselves. Oh yeah, by the way, energy and mass are kind of the same thing, he added, which explains why atom bombs are so freaking powerful. According to this,
we're done with the stuff that I have a complaint about, except for we could talk about literally everything in this video.
Right.
From electrons, which I've talked enough about how people get the electromagnetic stuff wrong, and they talk about, oh, by the way, this is funny. Shut up.
by converting chemical energy stored in your body to gravitational potential energy stored in the apple. As you may have known,
Silliness aside, this is an excellent explanation thus far.
energy and work have the same unit, joule, so they must be the same thing? No, energy is the total amount of work that a thing could possibly do, and work is just the stuff that actually happened and required energy. If you
Very well said. Energy being the capacity and work being the actual transfer.
lift a weight that's too heavy for you, you'd feel like that took a bunch of work, right? Well, yes, but your feelings are invalid in the face of physics. Mathematically, no work has been done, because work...
Do or do not. There is no try. I don't give a shit what you think. I could be pushing on a electromagnetic closed door, applying a lot of work, getting nowhere, because the door is like fused to the other magnet and metal parts of the door. Like you can't open that shit. You gotta like block the electromagnetism or turn it off in order to actually move the door. That being said, if you had enough force, you could still be applying force and doing work to move your muscles and do all that pressure. That doesn't actually end up with a motion of another object, but it is the tensing of the muscles and everything that did occur. So it doesn't matter if you move the weight or not. you still expended energy. You still burned joules of energy. It just didn't get you anywhere. Like having the brakes on while you have your foot on the pedal. You didn't get anywhere. You used a lot of gas. Please don't say stupid statements, for God's sakes.
Is force applied over a distance, and since you didn't move the weight at all, no distance means no work.
Yes, you applied a force.
No bitches? So the thing is, no, you applied lots of work. And the problem is, okay, if you want to move a ball or a boulder, the best thing to do is to try to push it in a direction similar to its rotation so that you're actually moving it. Also, if you add like a big ass lever to it, then work over time is multiplied and you can move that rock no problem. What you're experiencing is not no work, but ineffective work. The wheels spinning while you have the brakes on and the gas going. Or, yeah. It's crazy that science communicators are able to make these statements and not have the scenario of, oh, it's like your car, like, listen.
Force, but you multiplied by 0.
The key thing to remember about energy is that it cannot be created or destroyed, only
converted,
aka the conservation of energy. Okay.
Before he makes his statement, I'll make mine. Because I've already seen it anyway. You can totally destroy matter. It doesn't matter if you convert all that matter and its potential energy and whatever else into heat, and that heat dissipates because everything just settles down, because all the other energies and everything just turns into room temperature eventually, or cold if you're in the Arctic. Yeah, no, energy is totally destroyed all the time.
But a car that's moving has kinetic energy.
And in the classical
Funny, you mention cars now.
Conservation of energy holds. It's only when you get to really weird scenarios where you take into account the curvature of space-time where it does not hold up.
Or stops, assuming the car doesn't smash into a wall, where does that energy go? When you apply the brakes, there's friction between the brakes and the wheels, causing the car to slow down and creating heat as a byproduct. That heat...
Explain that in the terms of magnetic regenerative braking.
Is then dissipated into the surrounding air, and that makes the molecules in the air move faster.
Basically, all the energy went into the motion of the electromagnetic current, so instead of going out into nowhere, the regenerative braking stuff makes it so that it's translated into power again for you to use with your...
Things that move have kinetic energy, so ultimately the kinetic energy is transferred from the car to the air. With this knowledge, we can define that temperature is just the average.
So I basically said, instead of it converting it from the car to the air, it's converting it from the car. What if you have your car on a conveyor belt? Well, if the conveyor belt is moved in the same direction as the car, it'll go faster. But if the conveyor belt's moving in the opposite direction of the car, because it's wheel momentum based, not like a plane, like an idiot. Because planes work by moving the air, not the ground. Yeah. You'd end up being able to spin your wheels without actually going anywhere.
Kinetic energy of atoms in a system. You see, all atoms, not just molecules in the air, wiggle like this. The faster they move, the hotter things get. That is...
So anyway, just to say, I I haven't watched the full video, but I've responded to the parts where I had the most immediate problems. Let's pause. Ugh.
And as far as which one yields more energy, depends on the interaction, of course, but generally for an individual event by a mass proportion, fusion typically releases about 3 times more energy. The problem is fusion power plants require so much more energy to induce the fusion, which is why no one's made a working fusion power plant. They've all
No one has attempted to make a working fusion power plant.
been experiments that have never produced electricity on a commercial.
They have also never been designed with power generation as a component of the reactor. ITER is also not designed to make power. It is an experiment. It is not a power generation plant. It's not an inefficient power generation plant. It's simply not generating any power whatsoever. It's just making heat. It does nothing else. There are no heat transfers added to the system to gain use of any of this heat that we've made ever. Fusion power plants have been designed simply to experiment on the idea of making heat and make that heat stay hot. But these idiots don't even use sound. What do I mean? Well, it's pretty obvious that electrons and protons are able to be the positive and negative parts of an atom are able to be affected by electromagnetism. The big tokamak reactor has tons of electromagnets. Great for holding those parts. What about the neutrons? What are we using to hold them? Nothing! We're holding neutrons with actually nothing. So what can hold the neutrons in place? Sound. Pressure waves, by making a specific set of an inverted base golf ball inside of the design of the tokamak, would make it so that you can make sound that travels inward, outward, and then it will make, if you design it correctly, it will make standing waves that can hold the neutrons in place so that they don't just fling off so easily. Also, try only using electromagnetism and sound. Stop using inertia, because that will not work. Inertia will never work. Okay, in order for inertia to work correctly, you need a mass big enough that it actually is able to pull in the material. You need an effect that can pull in the materials. So you either need a mass that's capable of pulling in the materials, or you need to have some other effect, like using sound waves. It's possible to make a virtual version of gravity by having the sound waves make these standing waves, these standing nodes, where stuff is held in place, and that can be pulled, maneuvered, so that the sound interacts at different places, forcing all of those standing positions to move more towards the center of your contraption, and repeat. Kind of like how your guts push around the material that's inside of them. That, but using sound to control the neutrons. Once you got that going, you can make a neutron star for all I care. But seriously, we have never made a reactor with any power generation as a component of its design. It's never happened once. The only people who actually do that idea are the guys at Helios. They actually incorporated power generation as part of their design test phase to give you a benchmark of this under a load, to try and see just how actual much power you can get out of this crazy machine that holds plasma and does stuff and is still not using sound. Helios, we gotta talk, because you're screwing it all up if you're not using sound. Stop trying to be bigger. That's not enough of the solution. You need to just make it, I mean, you can make it bigger, that's no problem with that, but you need to also make it so that sound is incorporated, or you will never make a good reactor. It will always break itself, it will always have inefficiencies, and it will never give you the amount of power that you're hoping for. Because literally, if you have more neutrons to work with the interactions with all the other protons, then you can make hydrogen and helium and stuff more often than not. If all the neutrons are gone, how can you make helium? You can't. How stupid is that? Pull the neutrons back in and then you got it.
Commercial operation scale.
Or you might just blow up the planet. That totally...
It would take a ridiculous number of nuclear weapons to destroy any planet, far beyond which that we're capable of. It would be relatively easier to just knock the Earth into the sun. Still ridiculously hard, but compared to...
If you set off a nuclear detonation on a section of ground that has raw uranium, you're still not going to blow up the entire planet.
Making enough fission or fusion weapons.
Totally didn't almost happen before. Multiple times.
Yeah, no sarcasm. It didn't.
Yeah.
Remember when Einstein said light is a particle? He accidentally discovered a whole new field of physics which he thought is just a giant hoax. Quantum mechanics. This stuff is crazy. Another German guy called Max Planck said,
Yeah.
Yes, Einstein, you're right. Light does come in tiny packets. Actually, all energy comes in tiny packets, or quanta. Want to know where an electron is inside an atom? It's here, and there, and everywhere at the same time, actually.
Another
Hold on.
probability function.
It's a super...
No. And not superposition. Not superposition. That's not what that means at all. It literally exists in all of those places because it's moving so fast. It has visited all of those places at the same time. It's actually moving so fast it interacts with itself. It's like if you were to orbit the planet and be so fast that the front part of you, let's say the front part of you is able to arrive before the back part of you has left. How fast is an electron really moving? Compared to the atom, it's moving 22 quadrillion atomic mass width per second. 22 quadrillion of anything compressed into the orbit of an atom? Yeah, you're going to look like a blur. It's not superposition. They literally do exist. And or did exist. Step forward 2 femtoseconds and it exists there, and there, and then there, and then there, and there, and there, and then there, and then there, and then there. Quadrillionths of a second. That's how fast it moves. That's how many copies are. You divide the 22 quadrillion by... How do I get 22 quadrillion? The actual speed recorded by people of the electron is 2.2 thousand kilometers per second. A stupid number relative to literally nothing to do with electromagnetism. You might as well say 2.2 million meters per second. Much more relativistic idea because, hey, guess what? 300 million meters per second is the speed of light. So it's approximately 1/150th of the speed of light. Slightly more than 1/149th or something percentage of the amount of the speed of light. Speed of light goes 149 times faster than electrons. So, something like that. Don't quote me, just this is about the same thing. The thing is, when you actually scale it down instead of kilometers, which is stupid, meters, which is still stupid, when you go down to nanometers, the size of an actual atom, 1/10 of a nanometer, you get the 22 quadrillion I'm talking about. Because that's how many of those it would have to travel past in order to get the full distance. It travels that in a second. So yeah, if you coil that up around an atom, yeah, it's going to look like a blur. It's not a superposition. It literally exists in all of those positions that you notice the blur being. That is the electron. If it's just one, small blur. If it's more than one, bigger blur.
Superposition. It's not in one state, it's in multiple states at once, at least until you measure it. Then it chooses one cozy spot to be.
That's because it's literally one thing taking up a lot of area because of its distance over time is extreme in the form of 22 quadrillion parts per second. So yeah, that around an atom, crazy, lots of it. Yes, all at once. It's just one thing.
Schrödinger gave us an equation that gives you a probabilistic model of where you can find it if you were to measure. You can imagine this as a cloud, and the denser it is, the more likely it is for an electron to be there. But still, where exactly it will end up once you measure it is...
Where exactly you end up has to do with if you're measuring where it is down to the 1/quadrillionth of a second. If you're not that accurate, you're not trying to measure where it is. Stop trying.
Random. Speaking of observing particles, they're also super sensitive about their private data. Look at these two images of a flying ball. In one, you can clearly see where the ball is, but not in which direction it's moving.
This is very
and in
good.
the other, you can see where it's moving and approximately how fast, but not where exactly it is at the moment.
That is a great way to demonstrate that.
Yeah.
Is essentially Heisenberg's uncertainty principle. You can never know both the exact position and the exact speed of a quantum particle at the same time.
Unless you have a processor or a sensor that is able to move or sense things at the level of quadrillionth of a second, right? Or near light speed. Recently, they did a study talking about light that is changing frequencies is a more faster sensor because the difference between each frequency can also be differentiated. So you can have faster than the speed of light sensing equipment because the differences are also recorded and noticed. So you're actually able to make extreme good accurate measurements of electrons and know exactly where they are as long as your processing power is capable of taking in a few petabytes of data.
Okay, let's recap. A small thing can be a particle and a wave at the same time, and when we try to look at them, weird stuff happens. But you know what? It gets even weirder.
It's not that when you try to look at them weird stuff happens, it's that when you try to put an electromagnetic beam towards a goddamn thing that works with electromagnetism, called electron, yeah, that beam's gonna make it move. How much? If you compensate for that, then you know exactly what else it was gonna do otherwise.
Think back to the double slit experiment. We know
Shut
that
up!
a light beam acts as a bunch...
I am tired of this! Say it right or I will ban you to the Shadow Realm.
of waves and we get interference. But here's the weird thing. Even if you send individual photons, after sending enough of them and detecting where they end up, you get interference. Like,
Good luck sending individual.
Look. Yeah, that's because you're talking about electromagnetism as if it's... Photons are still a particle. The electromagnetic field is not the photon. It's a separate thing. Or when you're actually doing this, the double slit experiment happened with electrons. If you're seeing this with photons, okay, whatever. But if you're seeing this with electrons, electron is an actual packet of little tiny something. It has mass. It is a thing, unlike photons, which are just the excitations of stuff. Unless a photon is actually a packet, which is physical, like an electron, but it's the tiniest of said particles. Actual physical phenomenon. Unlike the electromagnetism, which is a separate thing. It is tinier. It is the reason why there's an energy connection of the electron to the atom at all. And the electromagnetism is also seen as the reason why wires travel the electromagnetism through them. All the electrons are doing things, but that just excites them. The field is what moves through the wire. The electrons hardly move at all in the wire. But the field is able to be excited and move through the wire. The waves of the energy. Knowing the wave-like properties of the electromagnetic field and applying that to the double slit experiment, you can understand why there's an interference pattern, because the waves go through the double slit, they hit each other, and they turn into a thing. And that determines where the photon is going to end up. Or the electron is going to end up. It's so frustrating when you talk about the field and you say it as the same thing as the electron or the photon. It's not.
Photons, too. That's hard to measure.
Can that be? What did a single particle interfere with? Well, we think it interfered with itself because it acted as a wave and went through both slits at the same time. That's a superposition. Okay, well, let's just...
It doesn't do that. The photon did its own thing, like a little dot will do. And the electromagnetic energy that is around it is what goes through, makes the interference pattern, and dictates where it's going to go.
Measure which slit it goes through.
Try asking it, it'll tell you what position it went through. Just kidding.
Yeah, that's not gonna happen. Once you start measuring which slit the photon goes through, it stops acting like a wave and
That's because you're putting a beam of energy, okay, in the way of the path of the electromagnetic field itself, negating the electromagnetic field's wobbles, and making the area behind that beam basically unaffected by the wobbles whatsoever. So the particle that goes through only goes through the basic, non-interfered space.
interference pattern disappears, as every particle chooses just one of the slits to go through. Sounds kinda suspicious to me. Anyways, all this knowledge...
Yeah, no, this is why I kept recording, because... Fucking stop! Please! Every time I hear about the double slit experiment, you're saying that you don't understand that the electron and the photon, apparently, also are dots that are being affected by a fluid. You suddenly cut off the weird motion of the fluid and you wonder why it then makes the photon go in a regular pattern. That's because this thing that made the electromagnetic wave turn into the interference pattern is the electromagnetic energy, the field itself, not the photon, which is excited particle. If the photon was electromagnetism, the beam would have stopped the photon from going through to the back plate in the first place. That's not what happens. The photon is a physical entity, a tiny little dot of wibbly-wobbly energy that is going through that field, through the beam, and hitting the other side. And if you don't understand that basic principle, you're not trying to be a scientist, you're just listening. And I'm sorry, but a science communicator has to actually apply the science, not just listen. I accuse you of this, Tyler. Unless you do the experiment yourself, which, oh wait, I haven't, but I know it. It's tiring. I don't want to... Every time I hear the double slit experiment, it is misquoted, or the parts of everything that is happening are like, oh, well, we can't draw any conclusions out of this. Toss it out, I guess. Instead of actually looking at what happens. Oh yeah, why does it do that? We all know. Yeah, we freaking do. Listen to me. You get it. I'm not the only person who should understand this, but I'm the only person on the internet who has ever said it. Everyone else who I listen to about this has never said that the electromagnetic field and the electron are separate things. Except for Veritasium, when they talked about electricity going through a wire, they said it correctly, but they didn't refer to it in regards of the double slit experiment because they're cowards. Or they didn't think to bring it up. More likely the second half. I don't think that I don't think there's like some cover up. I think they're just not focusing on the details. They're not trying to learn. They're just spitting out the same things that we had back in the 50s and the 80s, and no one has gotten any new insights except for, hello? Welcome to Science Me, where I talk about science and I blow your mind with what actually fucking happens. This is why I don't do these reactions more often. I get physically fatigued watching this nonsense. And it's not just about him. It's about the source video. And it's not just about the source video or him. It's about every scientist believes this nonsense. And I'm tired of it. I am really frustrated with it. It'd be one thing if it was just one person making a mistake. No, this is the entire scientific community making a mistake. Every time. It doesn't matter who. I have no bias against anyone except for they're not using their heads, actually analyzing, actually trying to figure out what's going on. They're just taking it for granted that the other people who did the experiments know what they're talking about. Is that the scientific method? I don't freaking think so. One person thought that they made X-rays, right? Because they had some weird lamp and some light showed in some other part, and they couldn't figure out why, and they couldn't repeat the test. But that led to the idea of X-rays, and they were researched, and they got into, and they figured out what actually makes those. But that person who made that original discovery or observation wasn't looking at X-rays. There was a reflection. They didn't account for. Yeah. That's what we call a false positive. Stuff like that happens all the freaking time, and I'm tired of it. I started with the whole train incident because fuck you. And it bought, oh yeah, the freaking light. The light nonsense. Screw you and the light nonsense. Screw you in this train. You're wrong. I'm sorry, you just are.
YouTube Premium is
Shut up.
ad-free.
Be the same as the speed of light? The reality is no.
How fast is this train going? A lot of these is like, I don't know.
I am actually disturbed that you said how fast is the train going, because the train speed doesn't affect the light speed. Don't you understand that? How can you make this statement, Tyler? How? You know what affects light. Barely anything. The train moving at relativistic speeds wouldn't do anything to what the measurement of the speed of light moving through the train. Has zero effect on the light whatsoever. The thing that you would notice if you start moving faster than the speed of light is that there would be this big bright ball where the light is trying to be emitted, and it would shoot backwards, start grinding through the material. Right? Light would still be emitted, but it would automatically impact the light bulb and shine a laser backwards out the back of the train. It would be still going at the speed of light. It would still be going eventually to catch up with the train, but it would shine a light laser directly through the train going backwards because of the light bulb would break and it would stop shining light. But if it kept shining light, the light that interacts with all the materials would just be mostly absorbed, and then, yeah, you would just have a burn. It wouldn't shine all the way through the thing unless you have the light just keep going and keep on burning stuff behind it. Like, just shine the flashlight backwards and you get that effect. Well, okay. Depends on how intense the light is. So, it would all bunch up, it would make a very bright spot. Then that spot would start getting hot. The faster you go, the more... Well, it doesn't change the fact that there's only a certain amount of light exempt from the bulb heading towards that back panel. So you can't change that fundamental. It doesn't matter how fast you're going. Yeah, the photons hit with a bit more kinetic energy, which is great for solar sails, but the point is it's going backwards relative to the direction of travel. So it would make it hot, and it would burn that back plate. If the train is going faster than the speed of light. If you're going near the speed of light, then you would start seeing the light be similar speed to the train, and it would actually have to, at some point, would have to actually start catching up to the train when you're going faster than light. But before you get there, right, you would see the light actually progressing slowly through the train. That's simply because it has to keep up. It still doesn't give a shit that it's in a train. It's just light that's moving. Right? For a prolonged period of time. Disgusting!